just a spin on the same old, same old. So a little bit about Cohesity, the company. For those of you that might not be completely familiar with us, we were founded in 2013 by Dr. Mohit Aaron. Dr. Aaron was one of the lead architects on the Google file system. That's the distributed scale-out file system that Google is using to store all the data they're collecting about you, your friends, your family, and so on. He went on to co-found Nutanix, a hyper-converged virtualization platform. So we've got a pretty strong pedigree, history, and in particular vision when it comes to hyper-converged infrastructure and massive scale-out architecture. Something to note that even though our doors opened in 2013, our actual product has only been shipping for about 3.5 years. So we spent a lot of time developing the product. Nothing was rushed out to the market. The platform had a really high degree of maturity with the first release, and we've continued to innovate rapidly since then. And it's not on the slide here, but in the first month of this year, we received a net promoter score of 100, and we're still maintaining a 90 or above currently. If you're not familiar with Net Promoter, it's essentially a ranking from -100 to +100, and it's based on satisfaction surveys of your customers, largely around how likely they would be to recommend you to another organization. So that's really cool to receive the highest ranking of satisfaction from our customers. And another important group of pretty satisfied people is our investors. You can see we've got some pretty prominent investors backing us. And in April of this year, we received our Series Z funding of $250 million. And I think that really speaks to the confidence our investors have in the product, that they would invest in us and give us this funding right in the middle of a global pandemic and some pretty uncertain financial times. Okay, so what is this great product that I love and everyone else loves? And more importantly, how does it help us redefine enterprise data management? Let's start by talking about the data that exists in the enterprise today. First up, you're going to have your mission critical tier 1 app data. These are your business databases, your order processing systems, virtual machines, all of those workloads that are often real time and transactional in nature, where the end user experience really can be affected by latency or other performance metrics in your storage system. We're not going to be terribly focused on these workloads today because while they're very, very important to your business, they typically represent only about 20% of the data you're responsible for. And there are plenty of players in the tier 1 storage space already, Pure Storage, for example. And those guys are all focused on pushing the limits of latency and throughput, and they're doing a damn good job of it. Our platform is really focused on data integrity, availability, efficiency, and we believe there's a lot of innovation to be had around how we manage that other 80% of enterprise data. In this space, you're not going to find the same stringent performance requirements. We've got use cases like file storage. These are your home directories, your document repositories, your emails, things like that. Again, these are important to your business, but they maybe don't need to reside on that ultra fast and often expensive storage. We're also starting to see requirements around object storage. These are data sets for your next generation or cloud native applications that rely on things like the S3 protocol. And I've probably got a couple copies of at least a portion of all this data somewhere else for test and dev. And here in this environment, I can probably tolerate slower throughput and a little bit of higher latency here, as long as it's consistent. And of course, once I have all of this data, I need to do something with it. I've seen it stated that data is one of the most valuable assets to a business, aside from its people. But just having data doesn't generate revenue or generate better business. It's what you do with that data. How do you extract the trends and other critical information needed to make good business decisions to drive success? So I've got a lot of analytics and evaluation of the data I own. And then, of course, there's reporting requirements for things like compliance with GDPR or HIPAA. I need to understand where certain types of data are in my environment. And not knowing where they are can have cost implications to a business in terms of fines and things like that. And all of this analysis and reporting often means creating another copy of the data where that analysis or that reporting can be done so that I don't impact my production environment. And now we're going to come to this last use case, and everyone was probably thinking it was going to be the first one, right? A final, very important aspect, data protection. I've got all this data. I know it's important to my business. So what do? I make copies, lots of copies, and I store them somewhere just in case something bad happens. This is a pretty complex and expensive insurance policy. And of course, in the real world, all of this data isn't organized into the nice, neat columns I've put on the screen here, right? We've got it distributed across multiple locations. I've got multiple data centers. I may have branch offices. And now we're starting to see, a hybrid public cloud environment. How many of you are looking to leverage cloud storage for either infrequently accessed data, or are you looking to maybe move some workloads to the cloud? How do you get the data and those workloads into the cloud? And then how do you manage those workloads and that data once it's in the cloud and out of your data center? And of course, all of these, locations and point solutions, they've got things like storage frames. I've got servers. I've got data proxies. I've probably got some cloud gateways if I'm doing anything with the cloud. And then I've got compute infrastructure to run all those applications involved with managing that data, all that analysis and reporting and so on. And of course, they all have their own management interfaces, their own security implementations. They're almost certainly from different vendors, which means compatibility issues, various life cycles, different cost models, and separate licensing considerations. Every single one of these suffers from some form of scaling challenge, right? If I scale up the amount of data I'm managing, well, I need to scale up that compute infrastructure to handle that additional data. If I run out of the ability to add disks to a storage frame, or I reach saturation on a storage controller, what do I typically do? I spin up another version or a bigger version of that storage frame right next to the old one, and I copy everything over to the new one. This is what we call forklift upgrade, and I've seen it over and over again. Now, what we've got on the screen here is what most enterprises today would refer to as data management. Now, I'm guessing nobody's bothered to really diagram everything in their environment like this, because no one would actually design something on purpose that looks like this. This evolves, right? This happened over time. New business requirements come along, acquisitions come along. No one really notices the complexity and inefficiency that's introduced over time. I look at this and I start thinking, well, that's more like controlled chaos, right? And some days it can feel like it if you're in charge of an environment like this. This isn't data management. This is keeping your head above water. You'll hear Cohesity use the term mass data fragmentation a lot, and that's exactly what this refers to. The data that your enterprise is responsible for is fragmented across multiple point solutions. And what does that do? That drives cost, that creates complexity, and ultimately inefficiency for your business. Now, you're going to say, well, Brad, that's a little bit extreme, right? And it may be, but I'm betting parts of it are resonating with almost everyone here. I can tell you, I've worked at small startups, I've worked at very large enterprises, and I've worked at global cloud providers. Every last one of them faced at least some of the challenges I just described. I literally made a living as an architect responsible for crafting workable platforms comprised of all these point solutions, and then wrapping a lot of programming and automation around all of it to make it look like one cohesive platform. So all of this complexity and inefficiency is the reason Cohesity was born. So Dr. Aaron saw an opportunity to take all the goodness of that large-scale distributed file system like the Google file system and apply it to an enterprise use case. So now we'll take a look at what Cohesity actually is, and then how it changes the way we think about data management. So at our core, we're a software-defined data management platform. Let's break that down a little bit. Software-defined means no proprietary hardware. We scale incrementally and non-disruptively on commodity x86 hardware, as a virtual machine, and in the cloud. So new features and functionality are introduced through software, not forklift hardware upgrades. The platform you invest in today, it actually gets better over time because we're able to introduce new capabilities and new features through software, not hardware. So you'll see there on the screen, we have our own Cohesity branded white box, but we also have partnerships with a number of OEMs and qualified models. So if you've got a preferred compute vendor, no problem. We're here to give you that choice and flexibility. You're not going to be locked into any particular proprietary hardware or even a particular compute vendor. So if things change down the road, we're there to change with you. And of course, the base architecture of this is similar to a large, Google file system. Think of that, of the amount of data that Google has to store. So we are designed to scale out and without limit. I mentioned this just a second ago. We have flexible deployment options purely because we are software defined. So it's the same platform running in your data center, at your remote offices, and in the cloud. This is a single unified platform, no more distributed point solutions. Same platform, same capabilities, no matter where or how you deploy it. And so we can start to leverage this scale out data management platform to start consolidating all of those scattered point solutions. So we're going to eliminate a ton of complexity, we're going to create a ton of efficiency, and ultimately save a lot of cost. So let's take a look at some of those very specific use cases. So I talked a little bit about data protection as being a very important aspect of enterprise data management. And this is probably what Cohesity is most well known for. If anybody had heard of Cohesity before, you probably said, oh yeah, those guys, they're a data backup vendor. There's a reason for that. This was the first use case we focused on because there's a ton of opportunity to innovate in this space. And it's a great way to demonstrate the power of our distributed scale out platform. So even within data protection today, there's a ton of complexity and cost. Think about the architecture of today's backup solutions, right? It's not just a single server and a single piece of software. There's a lot of moving pieces and they all have to be managed and scaled independently. So you'll have things like master servers, media servers, proxy or ingest servers. Of course, you've got some sort of target storage that I need to write all that data to. And if you're looking to leverage any sort of cloud storage, or maybe you're trying to protect workloads that you're running in the cloud today, you're probably looking at some sort of gateway appliance or software product to move data in and out. Now, when I look at that, I'm counting at least 2, if not 3 or more vendors involved with a typical data protection solution. Again, I've got separate scaling considerations, I've got licensing, renewal cycles, and so on. But because we're software defined with a true scale out architecture, we can converge all of these components and functionality into every single Cohesity node in a cluster. So any node in a Cohesity cluster, it is a master server, it is an ingest server, and it is the target storage. So what does that give you? Fast distributed ingest. The more nodes you have in a cluster, the more pathways we have to pull data in. And because we store data in a native format, with our snapshot and cloning approach, you're able to instantly present backup data as live data. So in the event of a restore, you're not waiting for data to copy back over to your production storage. We are the live production storage, at least temporarily, and in the background, we'll go ahead and move that data back. Backup data is stored in our immutable file system. That's a fancy way of saying that once we pull it in, you can't change it. That's very important, and we'll talk a little bit more about that a few slides later. In addition to an immutable file system, we also have data lock. This basically prevents even an administrator from deleting backup data. Again, we'll talk more about a specific use case and why this is important to your business a few slides from now. And finally, we have global dedupe across all data and workloads. This means the more data you throw at the Cohesity platform, the more efficient your storage becomes, driving down cost. Our dedupe algorithm is a variable length sliding window algorithm, which translated from nerd speak equals 25 to 40% better dedupe efficiency than the fixed block algorithms used by most other storage vendors. Well, but Brad, if it's so great, why isn't everyone doing it, right? Well, remember when I said Cohesity wasn't focused on those tier one workloads that require extreme performance. This is part of the reason why. We're focused on ensuring your data is stored in the most protected, integral, and efficient manner possible, and there are performance trade-offs in doing so. So let's go ahead and turn our attention to another use case that's, ripe for optimization. All of that unstructured data we're storing, all of that documents and emails and object storage, right? We saw in the earlier slide, this data is often spread across multiple silos for any number of reasons. You've got some data that's SMB or NFS native. You've got some data that is accessed over S3. Maybe we've got data in some public clouds. We've got data in remote branch offices. Again, all point solutions, lots of inefficiencies. Let's go ahead and leverage this scale out platform and start consolidating them. We natively support presenting the exact same data set over all three protocols, NFS, SMB, S3. That's true unified access to all of your data. I don't have to create multiple copies. I don't need to migrate anything. I simply present the same data over multiple protocols. We're going to eliminate all those individual management points. Your data is sitting on the same platform, regardless of whether it's in your data center, a remote office, or the cloud. The way you manage the data is the same. You can search across all of your data and get results regardless of where it's sitting. And we also can leverage native cloud storage to move cold or infrequently accessed data to a cheaper tier. So if you've got a bunch of files that have maybe been sitting around on some storage for years and years, and you're just keeping them for compliance reasons, well, we can actually tier those off to a cheaper form of cloud storage, and there's no impact to your end user. Okay, so we've got all of our backup data. We've got our file and object data. We've got this single unified platform. Why don't we start leveraging all this data and just turn around and use it for our test and dev environments? So the Cohesity platform has some really advanced snapshot and cloning technology, and it allows us to create instant zero-cost clones with no performance impact. So we can take that backup of your virtual machines and instantly represent a copy of that data back to a compute infrastructure to create a test copy of those VMs. Have them powered on and running in just a couple of minutes. Let's contrast this with having to create copies of your production VMs and move those over to a separate dev and test storage system. Not only do you got to procure and manage that storage, you're also waiting for those copies to complete from production to your test environment. If you're already doing backups, you're already creating copies, why not take advantage of those copies? We can instantly create a live copy of that VM or that file and object data and represent it as a clone that can then be used in a dev or test environment. You say, okay, great, Brad, but I still have to maintain all the compute infrastructure for a dev and test environment. Well, one more thing we've got up our sleeve is something called CloudSpin. CloudSpin can take your VMs, and when we do a backup from your native on-prem format, your VMware, or maybe you're running Hyper-V, and we can copy those straight to AWS or Azure, and we'll convert them to those native formats along the way. So now you can actually take copies of your on-prem VMs as part of your backup process and create copies of them in a public cloud, spin them up, and use them as a temporary test and dev environment. All right, we're almost there. We've removed all this complexity. We've consolidated those data silos. We've got a bunch of cost savings by doing all this consolidation. We've got massive efficiency with global dedupe. But there's a few more pieces here. So one, let's make all of this data accessible and manageable through a single unified interface. No more point solutions. Wherever my data is sitting, I can access and take action on that data through the same management interfaces. Maybe I need to search for a particular file. And if you're dealing with multiple locations, data centers, clouds, etc., this might be a laborious process. Here I've got a single interface that lets me globally search all of my data, all live systems, locations, all backups, find out where it's at. This interface is called Helios, and it also gives me some real-time monitoring and reporting, so we can be alerted to anomalies in data usage and storage patterns happening across all of my environments. I don't have to go run reports out of different platforms and different management interfaces. I've got one single place to access all of this. And then finally, we talked earlier about data, the contents of the data being a valuable asset to a business. And so being able to extract information from your data is really where the value is in maintaining and storing that data in the first place. So in our earlier example, we had a whole bunch of compute infrastructure, maybe some additional storage, all to handle things like analytics and reporting. This is not only costly, it's super inefficient. We've got to move data from one location to another, do our analysis, do our reporting, write out the results somewhere. So we've got all this data on this great scale out platform. Why don't we bring the apps right where the data is already sitting? So with Cohesity, you can. Because we're using a hyper-converged infrastructure, we already have compute available in every node in the cluster. So we go ahead and deploy a Kubernetes stack right on top of our platform, and we'll run those applications as containers right where that data is already sitting. So in addition to things like analytics and reporting, I can also extend the functionality of the Cohesity platform through this manner by running applications, right? I don't have to wait for Cohesity to add a feature to the core product. There might be an app that does it today. For example, we just recently released an app called Runbook. This is an application that helps you automate things like disaster recovery. It's essentially a workflow type GUI where you can say, these VMs need to come on first, and then these VMs come on and change these IP addresses and so on. So I can automate things that would normally take a lot of time, and this will significantly reduce things like recovery and even normal day-to-day operations time. In addition, we've also got things like antivirus and vulnerability scanning to help ensure that your data and your virtual machines remain secure without all of that additional infrastructure or performance impact those types of activities can incur on your production environment. This last one is particularly critical, especially with some of the headlines we've seen in the last few weeks. So I want to take a few moments just to talk about how building your data management strategy around Cohesity not only gives you all this great efficiency and reduced costs and reduced complexity, right, but it can also dramatically increase your organization's posture when it comes to defending against and recovering from a cyber attack. So, ransomware today, by some estimates, is an annual $2 billion criminal industry. That's a lot of money. I'm in the wrong line of business, I think. The FBI's Internet Crime Complaint Center in 2019 received a little over 2,000 reports that were identified as ransomware attacks. And that's just the people that bothered to report it. And depending on which study you read, again, because not everyone reports ransomware attacks, there's an estimate between $7.5 and $11 billion as the average cost to an organization. And that's kind of a combination of downtime plus any ransom that they actually paid. And while we're seeing the overall velocity or frequency of these attacks kind of trending down somewhat, the sophistication is really increasing. The attacks are becoming targeted at very specific environments and even very specific organizations. You don't need to look any further than the headlines a couple weeks ago, right? I'm not picking on Honda here. I'm kind of highlighting it to show that if an organization as large as Honda can suffer nearly a week worth of downtime, it can happen to anyone. And this also highlights how sophisticated the ransomware was. When the researchers actually opened up the ransomware and tried to evaluate it to figure out what it was, they found it stayed dormant if the DNS servers didn't respond to a known internal Honda domain name. So basically, the ransomware wouldn't run at all unless it knew it was sitting on an internal Honda network. So it was very, very specifically targeted at Honda. So if we go back to our traditional data management architecture and strategy, if ransomware starts spreading through this environment, what's your strategy to deal with it? How do you get your data back? How do you get your business running again? Are you going to pay the ransom, or do you have something better that could get around this? You say, well, of course, Brad, we've got backups. We'll go ahead, we'll restore from a good copy. And that is absolutely a valid response. But with all of these different systems and different capabilities and different formats and different management interfaces, how long is that going to take? Have you actually tested recovering massive amounts of data from your current backup solution? And even if you did, that's a controlled test. Imagine trying to do this while the clock is ticking. And the entire time you're working to recover all of this data, your business is down, which means you're losing money. This is one of the reasons that businesses choose to pay the ransom. Yeah, we've got backups, but the time to recover is more costly than simply paying for the keys to decrypt the data. A couple other things I want to point out. Almost all major backup solutions today contain Windows OS-based applications, right? What OS is most likely to be targeted by ransomware? I'm not picking on Microsoft or Windows here. I'm saying it's the world's most popular operating system, so it's probably going to be targeted. If your backup product is built on top of Windows, you run the risk of increasing your recovery times if you need to rebuild your backup platform first. Second, how is your target storage for those backup products exposed on your network? A lot of times they're just wide open over SMB or NFS. And so even if ransomware doesn't target your backup servers per se, it may stumble across the backup storage from an infected system. The effect is the same, your backups become encrypted and you can't recover. And then finally, remember when I said these attacks are becoming more sophisticated? There are actually instances now where the ransomware is specifically looking for backup, common popular backup products in the environment. And we're going to go ahead and encrypt that first before I start going after your production data. And this is a great way to make sure I get paid, right? The potential loss from having to go back to very old backups, maybe stored off-site somewhere. I think I'm just going to pay the ransom, because to rebuild all of that business data is time and money. All right, so how does Cohesity make everything better? We can't promise that you won't be attacked by ransomware, but we do offer a multi-pronged approach to ensuring your data is available and quickly recoverable in the event of a ransomware or similar attack. Again, going back, start with that immutable file system. When we ingest data, it's not exposed or accessible in any form other than through the management interface. There's no SMB or NFS access to your backup data. So already we've lowered the attack surface. And we're not running on a Windows OS. We've got a hardened Linux as our base. So we've further reduced that attack surface. And then, of course, you say, well, it's available through the management interface. What if they compromise, an administrator account? And that's where data lock comes in. Not even administrators can delete data with a data lock policy applied until the lock period expires. And then one more step to protect against administrator accounts being compromised. We support various multi-factor authentication schemes. That's pretty table stakes these days. And if ransomware does get into our environment, maybe we can get ahead of the spread if we can detect it early enough. So Helios, our unified management system, it does some machine learning, and it does some analysis of not only backup, set size. I was 10 megs yesterday, I'm 100 megs today. That can definitely indicate things are being encrypted. We also look at data usage patterns. So, hey, this file is accessed on average 20 times a month. Now it's being accessed 5,000 times in the past week. What's going on here? So we can use some of those alerts to maybe get ahead of a ransomware attack that's starting to spread through your environments. But the real power comes in when we leverage being able to run applications on top of all this data. So we can do things like vulnerability detection on backups of our virtual machines. We have an app called CyberScan, and it's essentially running the Tenable security scanner, and it can help you identify VMs that are potential targets for ransomware without having to run those scans against production VMs, which can have a performance or even downtime impact. And in the event you do have to recover from a backup, now you know which backup really is clean, and you also know which systems have potential vulnerabilities that may open you up to a rapid reinfection. So you can start to focus your mitigation when you recover these VMs. So how do we do it? One, we have unlimited snapshot capabilities with no performance impact. So some other storage vendors may talk about having snapshot capabilities, but they're going to want to ship those snapshots off site somewhere after a certain number. They only want to keep, the top 10 or so snapshots local. So one, we can create backups more frequently, ensuring you have a much more current version of your data. And two, we don't have to wait for a copy to come from off-site somewhere. You're able to store those snapshots locally. We also have what we call instant mass restore, and that's part of our cloning technology. You're not waiting for all of your data to be rehydrated and restored back to production storage systems. The data is instantly presented to your production compute infrastructure, and then we'll move the data back to your production storage in the background. But in the meantime, you're up and running. All right, so let's sum it all up. Let's give a final comparison here of everything we just talked about. So today, we store data in siloed systems, separate management interfaces, multiple copies of the same data. Cohesity, we've got a true unified platform, same platform for all of your data, no matter where it's sitting. Today's storage systems are often built on proprietary hardware. So you're locked into maintenance plans and upgrade cycles. We're software defined, so you've got the freedom of choice when it comes to hardware. And again, it's the same platform, regardless of where your data is sitting. All of today's storage solutions have some sort of scaling limit. Sooner or later, you're going to hit a forklift upgrade. We are a true distributed scale-out platform. It's been proven at massive scale. We've got massive upgrades that can happen non-disruptively, and you're going to avoid a ton of downtime compared to some of the more traditional storage platforms. Today's storage platforms are exactly that. They're storage. They do a really good job of holding on to your data. But to gain access to all the value provided by the contents of your data, you need additional software, you need additional infrastructure. We've got native global indexing and search on our platform, and then we can go ahead and run those applications directly on top of the data. Cloud has typically been an afterthought. It's been a gateway type solution, or there's some sort of software needed to translate the data to and from the cloud. We are cloud native, so we run in the cloud, and we can also leverage native cloud storage as an additional tier for your data management. And then finally, traditional storage, data security hasn't been a focus there. They were designed to store data. Cohesity, we're extremely concerned with data integrity and availability. So the architecture of our platform reflects that with the whole immutable file system, data lock, and then the ability to run applications on top that can help you identify vulnerabilities and the like. All right, there we go. Technical difficulties. So again, I really appreciate everyone here taking the time to learn a little bit about Cohesity and how we're working to redefine how everyone thinks about enterprise data management. I hope this has given you some things to think about around your own data management strategy. And of course, we and Core BTS would love to be a part of any of those discussions. If there are any questions, I'll be glad to take those now.
Yeah, Brad, we had a couple questions come in through the Q&A here, and thank you again for the great session here. First one is with CloudSpin. How does CloudSpin take a workload and move it into a cloud native platform, and how is that backed up once it's in the cloud?
Oh, okay. Lots of things to pick apart there. So we ingest the data in native format. So let's say you're running VMware on-prem. We're going to pull in those VMDKs. From there, we'll actually copy them to, let's say, AWS, for example. And we use Amazon's native translation service to actually do the conversion to Amazon's AMI format. We're about to release, or may have in the latest release, our own conversion tool, which is going to speed that up. It's a lot more efficient, gets that copy up into the cloud much faster. Once it's actually running in the cloud, that's exactly where Cohesity Cloud Edition would be a very useful addition to your data management strategy, because we're able to then re-protect that workload in the cloud without incurring any sort of egress charges that would be required to back that VM running in AWS locally on-prem.
Great answer there.
Another question that came in, Brad, is, and I actually see this talking to a lot of customers about Cohesity, is the minimum footprint for an initial solution for the Cohesity piece, you know, types of amount of hardware, that type of thing.
Sure. So for standard Cohesity deployments, the minimum number of nodes, meaning individual compute servers, is 3. So we've got a couple different form factors that are available for that. One of our models, again, and we have equivalent OEM models, actually stores 4 nodes in the same 2U chassis. And then for remote offices, we can actually run as a single node. So we do support single node clusters, but we only support those for remote offices because we expect that data to be replicated back to a larger data center where we can do things for data availability and resiliency. And then, of course, we also do support virtual edition, and the same sorts of guidelines apply there. Typically, for a production system, you're going to have 3 virtual machines, but we do support a single virtual machine for remote office type applications. Anything else?
Great. Brad, the other question that came in was around non-virtualized workloads. Which platforms, which workloads do you support that are non-ESX or Hyper-V based?
Pretty much all of them. There's a pretty extensive list out on our website, but any of the major operating systems like Windows, Linux, we do support physical. We have an agent that you need to deploy for those. And then we also support a large number of popular databases such as Microsoft SQL Server and Oracle. So if you're running any of the very popular enterprise applications or similar, we probably have an agent that can target those specifically. We also support backing up O365 data. So that's another important consideration as you begin your cloud transformation and you're moving a lot of services and data to things like O365. How are you backing that data up and maintaining copies of it for things like reporting and legal compliance? So if there's a piece of data you own, we've probably got a way to back it up and manage it.
All right, great. Well, I don't see any other questions here on the Q&A. Brad, thank you so much for your time here and for the great presentation. As always, this is a very interactive session. The entire day is designed around interactiveness. So please go visit Brad in the booth if you have an individual question for him. You can reach out and actually interact live with him and his Cohesity counterparts in the exhibit hall. So somewhere right above my head here, there's a link you can click on to exhibit hall. Cohesity is also giving away some pretty sweet giveaways. I'd say it's worth your while to stop by and check it out. If you click on the giveaways tab underneath the chat on the right-hand side of the window, this would be left-hand side of the window, click on giveaways there. You could enter to win, I think, one of 10 Amazon gift cards. So Cohesity team really stepped up some pretty sweet booth swag for the event here, because we can't do it in person. So and I'll give you something you could use to go out and buy something nice and green for yourself. So with that, if there's no other questions, again, please go out and visit the rest of the booths in the meantime. Go ahead, Missy.
We did get one more.
Oh, great. Go ahead if you want to ask it.
Yeah, so can you speak on the AI capabilities of Azure once you have your critical information in Azure, and how an organization can get more out of the data?
The AI capabilities of Azure. I'm not sure that there's a direct integration there. Again, so the same Cohesity platform can be deployed in Azure, and you can use that to store and manage the data with all of the same capabilities that you would do on-prem in your own data center. So if the data is in Azure, then you could certainly leverage any services Azure provides to do analytics or analysis of that data residing on the Cohesity platform. We're certainly able to present that to those services. So you would be taking advantage of all the goodness of Cohesity, like dedupe and compression and so on, saving you storage costs in Azure, while then also being able to avoid egress charges and things like that, because your data would be residing right where those Azure services are running.
That's a great point, right? Avoiding the egress charge is a big one right there, right? Because you could natively kind of work on the data. I'm thinking like a test dev work use case would be perfect then at that point for Cohesity, being able to spin up the instant clones to be able to take advantage of, working on that in Azure, right? Inside of Azure. Likewise too, the indexing of the workload itself too. So definitely it's a lot you can take advantage of there.
Yep.
Great. Okay, well, I think that about wraps us up here. Again, thank you so much for attending this session with Cohesity. We look forward to interacting with you throughout the rest of the day in the booths below. In the exhibit halls above, visit the booths, go visit Cohesity, as well as our other vendor partners and Core BTS. Of course, we have one out there as well. And if you have any questions, there are live people in the booth right now, all the way through 5 p.m. Eastern today. Please go ask them questions. They're bored, they're hanging out. We don't have any tchotchkes for them to play with. So go